When using access control lists or ACLs, it's always important to understand the flow of traffic that you're trying to control. It's important to understand if the traffic is originating from a trusted network and going to an untrusted network or vice versa. One of the challenges that you face using ACLs is that they do not maintain state information. One of the tools that can be used to help determine if the traffic is originating externally or if it's return traffic that was originated internally is the establishment bit. The established option looks to see if the bit is set and thereby is an indicator of where the traffic originated. Using the established keyword in an ACL will cause the inspection of the ACT and reset bits, which will indicate that the packet belongs to an established TCP connection. This means that the TCP connection has completed the TCP three-way handshake, SYN, SYN-ACK, and ACK. And when looking at packets coming into a trusted network, means that the connection was initiated from the inside to the outside. If we look at this example access list, access-list 102 permit TCP any established, interface Ethernet 0, and IP access group 102N, in this case, the Ethernet 0 interface would represent the outside or untrusted network, and when this ACL is applied to that interface, it will only allow packets with the acknowledge or reset bit set to pass. Any packets that are initiated from the outside network would be denied due to the fact that they will only have the SYN bit set and therefore have not completed the three-way handshake. Using the established keyword can be one of the tools used to enhance the security posture of a perimeter router. But since a router is inherently a stateless device, it doesn't replace the need to have a stateful firewall in the path as well. The principle of defense in depth, which states the need for multiple points of inspection on different platforms as traffic goes in and out of a network, should always be kept in mind. No single device can fulfill all the needs of a comprehensive security solution. Another example of how the above ACL would function is to take a close look at an FTP connection. FTP uses two separate ports, TCP port 20 for FTP data and TCP port 21 for control traffic. If we consider that a client workstation on the trusted network initiates an FTP connection to an FTP server on the external untrusted network, the initial packet from the client to the server will set the SYN flag in and presents the client's initial sequence number. The FTP server then responds with a packet that has both the SYN bit and the ACK bit set. The server will present its initial sequence number and acknowledge the client's initial sequence number. The client then completes the TCP three-way handshake with an ACK, acknowledging the server's initial sequence number. In this case, the packets from the server that are associated with this connection have the ACK bit set and will be allowed by the established configuration in the ACL. An important issue to consider when discussing FTP is that it can run in two modes, Ftp Passive Mode and Ftp Active Mode. In Ftp Active Mode, the client connects from a random port to the FTP servers on TCP port 21. The FTP server will specify the client's random port through the FTP control channel. The passive mode data channel is then opened with the client connecting to the server on the specified random port. In this case, both the control and data packets coming back from the server to the client have the ACK bit set. However, FTP standard mode will cause an issue with the data channel. The client will specify the random port to the server through the FTP control channel. The TCP three-way handshake then begins a TCP SYN sent from the FTP server to the client from the source on TCP port 20. This packet doesn't have the ACK bit set and therefore will not match the established configuration of the ACL. This case illustrates the need for a firewall which would track the state of the connection and allow both FTP standard mode and passive mode to work. Using the established configuration on a perimeter router can easily solve some of the issues with reconnaissance, such as someone trying to use ping or traceroute to discover the topology of your network. Any ping or traceroute traffic would be denied by the perimeter router, thereby preventing a potential leak of information about the network infrastructure.